So I'm here in Graz, Austria, with very privileged to have just interviewed Jorge Vago, who is the project scientist for one of the most exciting missions of the 21st century, the European Space Agency's Rosalind Franklin Rover mission, which is really going to do some great in situ sampling of the Martian surface below the subsurface for the first time. And it's going to be able to analyze the samples. I don't know if it's going to do it in real time, how long that's going to take, but you have a target launch of 2028. We're at the European Astrobiology Network Association's Conference 2024, and very well organized. And Jorge was just telling me that with the delay of the MSR mission, the Mars Sample Return, the Rosalind Franklin is become even more of a focus of the Mars community. Tell us why that is, Jorge.
Well, everybody is hoping that the samples from Mars will get back soon, but now that the first launch of MSR is likely to be postponed, then we have Rosalind Franklin to focus on, which is very complementary to Mars Sample Return. Mars Sample Return will collect surface samples, and we instead will investigate the subsurface. This is very important for the preservation of organic matter. And since Rosalind Franklin is looking for biosignatures or possible traces of life, it is very interesting to the scientific community to analyze samples from the subsurface because they are protected from ionizing radiation and from the environment on the surface of the planet, which is very hostile.
And with your mission, you will be actually able to detect evidence of microfossils or even extant life, existing life beneath the surface, which you don't expect to find, right?
No, we don't expect to find life beneath the surface at such a shallow depth. We drill only 2 meters into the subsurface. It's a big thing for planetary missions, but it's not a great depth. And the surface of Mars has such a low atmospheric pressure that you cannot have liquid water, which is a key ingredient for life, close to the surface. So I don't think we're going to find viable or metabolically active microorganisms.
But you would find potentially microfossils from previous epochs.
Right. The assumption or the hypothesis that we want to investigate is that life may have existed on Mars early in its history, some 4 billion years ago, when there was liquid water freely running on the surface because the atmosphere was denser, the planet being younger was being heated from below, so perhaps life may have gained a foothold on early Mars, and we want to see if we can find those traces.
And this is a European mission with NASA cooperation.
Exactly. We have established a very good partnership with NASA, and we are doing this mission together.
And you hope the best time frame potentially to get real data back, conclusive data, yay or nay, on microfossils on Mars would be what?
Well,
assuming you launch it, let's say you do go ahead and launch in 2028.
Right. So the landing is in 2030, and the reason for that is we're taking a long trajectory. We're going 1.5 times around the sun to make sure that we land during spring. And that is because a rover has solar panels, and it's during spring and summer that they can receive more sunlight for energy. But, so we start the science mission in 2030. Let's say we work for a good 6 to 7 months. I still think it would take us at least a year to process the data on Earth and really try to understand all the information that we get from the various instruments before we can say anything about the possibility of having found something interesting regarding life.
So thanks so much, Jorge, for your time today. We look forward to hearing more as the launch approaches.
Thank you so much, Bruce.